So this video, we're looking at solving inequalities, and when we solve inequalities, we solve them in the same way that we solve an equation, and that's really important. The only difference is that when you solve an inequality, you end up with a range of values, and that's pretty important because inequalities show a range of values instead of a single or one specific value of x. Okay, for example, so an equation, you get one value like x equals to 3, and inequality is a range of values like x is bigger than 5. So you'd have 6, 7, 8, 9. And then importantly, right, we solve inequalities in the same way we solve equations. And that is really key because we'll get straight into it now. So we'll go through a few examples and then I'll give you some to try yourself in a second. But the question is saying, solve the inequalities, so solve these two inequalities, giving your answers on a number line. So using our knowledge on number lines from the previous video also. So we solve an inequality the same way we solve an equation. So solving means you want to get your missing variable on its own, isolated on its own. So in this case, our variable is x. I want to get it on its own, and it doesn't an equal sign. We've got an inequality sign, but it works in the same way that we solve an equation. So I want to get x, in this case, being less than or equal to some number. And let's go through this one. I'm going to write the question down again below here, just so... Actually, no, we should be fine. Let's just go through here. This 8x means 8 times x. How do I get 8 on its own? Well, the opposite of timesing through by 8 is to divide by 8. And I've got to go and divide both sides through by 8. So this is just our balance method that we're very, very competent with. Let's divide both these by 8. They cancel, so that's good. Which means on your left-hand side of the inequality, you're just left with x, which is really good because the aim of the game is to isolate the x on its own. And I haven't got an equal sign. I've got a less than or equals to. And then 32 divided by 8 is equal to 4. So that is it. I've solved my inequality. So this here, that is my answer. Okay, that is my answer. And it says show your answers on a number line. So then we can go and draw a number line. So something, and let's do it in pen. Number line, let's go and draw it down below. And it's just, showing it, so nothing too fancy of a drawing. So something like this, x being less than or equal to 4. So 4 is going to be here. And because it is less than or equal to, it's going to be a circle that is filled in like this, because you do include the number 4. And we're going all the way less than or equal to 4. So something like that. And that is it. Okay, we have solved the inequality and I've shown my answer on the number line, which is down here. But with anything, or in maths, if we can check our work, that is always a really good thing to do. And this is quite a simple example, but just to show you what is really going on here, I'm going to show you how you would check your answer. So we're saying, right, any value of, and really I should go and label this because we're looking at x being here. This just means x is your list of numbers. So 4, 3, 2, 1, 0, so on and so forth. So we're saying the original equation said that 8x was less than or equal to 32. Any value less than or equal to 4 should satisfy, and that's a key word there, satisfy that inequality. So let's just go and choose a value less than or equal to 4, and it should make sense with our inequality. So let's go and use, I don't know, x being equal to 2. So if x was equal to 2, because that is less than or equal to 4, and we put it into our inequality, which is 8 times what our x value I've chosen to be 2, is 8 times 2 less than or equal to 32? Well, 8 times 2 is 16, and that is less than or equal to 32. So it makes sense, because again, right, this means less than, or equal to. So it does make sense. Okay, and similarly, if I put a value of x bigger than 4, let's just go and, for argument's sake, okay, I've checked it, it is absolutely fine. But if I used a value, let's say x being equal to 5, the inequality should break down because, well, what's 8 times 5? 8 times 5 is not less than 32. It doesn't make sense, which is good because our range of values should be less than or equal to 4. So we're just saying any value less than 4 will satisfy this inequality. Okay, and that is it. That is how we solve an inequality and show it on a number line and check through with our working. The second one, again, this is if we saw the equation 3x minus 5 equals to 19, you've seen this loads of times now. We can solve this. It's just balance method. So I've got that minus 5. I want to get rid of it because I want to get x isolated on its own, this time being greater than something. Let's begin by adding on 5 to both sides. Add 5 and add 5, which is good because then these two 5s here, they cancel because they're opposite. And you're left with, on your left-hand side, just 3x being greater than 19 over 5 is equal to 24. 3 times x bigger than 24. So to get rid of that 3 times, let's divide through both sides by 3, divide by 3, because then what happens there? These 3's, they cancel, which is good. I've now isolated the x on its own, and I've said that x is greater than 24 divided by 3, which is 8. So that is it. So any value of x bigger than 8 is my answer. Okay, so I've solved my inequality. And that is it. X is greater than 8. And again, showing my answer on a number line. So, I keep doing that, sorry. Pen in black. My number line, it is just a bit of a quick kind of sketch. So that's not very neat. Let's go and do it again. 8 is going to be anywhere on your number line. Let's choose here. And it's just greater than. So it's going to be a hollow circle, anything bigger than 8. There we go. And that is good. And again, let's just show you, what's really going on here by checking our work. We are saying any value bigger than 8, but not including 8, should satisfy our original equation. So let's just go and check that. Let's go and use a value bigger than 8, like x is equal to 10. That's quite an easy one to use. Is 3 times 10, so your x value is 10, take away 5, is that bigger than 19? Well, 3 times 10 is 30, take away 5, that is bigger than 19, because 25 is clearly bigger than 19. It makes sense. So any value bigger than 8 will satisfy that inequality. Okay, good. So now what you can do is you can try these 4 questions here, and then there's something else I want to go through on the next slide, so don't miss that as well. So you can pause the video, give these 4 questions here a go. You solve these inequalities the same way that you solve an equation, and then, yeah, so knowing that, you should be fine with these. So pause the video, give these a go. So you're solving these inequalities, you're solving them, and you're showing your answers on a number line. Let's begin. Question 1. So again, solve, I want to get the x variable isolated on its own. So in this case, let's go and divide through by 6, because I've got 6 times x, so the opposite times 2 by 6 is to divide through by 6, divide by 6, because then what happens there? These two, they're going to cancel, which is good, and we're just left with x being less than or equal to 36 divided by 6 is equal to 6, and that is your answer. Okay, it is as simple as that. And then to show this on a number line, that is the second part. Let's go and draw a bit of a number line over here. Your number 6 anywhere on your number line, and it's less than or equal to, so your circle is going to be filled in like this, and we're going all the way to the left. So any value less than or equal to 6 will satisfy the original inequality. Good. Number 2. Okay, again, solve this. I've got 4x take away 2. Well, let's begin by adding on 2 to both sides, because then what's going to happen there? Well, these two are going to cancel. They are opposite. They go. Good. I'm left with, on my left-hand side of the inequality, just 4x now being less than 14 add 2, which is 16. Let's go and divide through both sides by 4, because then the 4s will cancel, because they are inverse operations. So these cancel. So we get x being less than 16 divided by 4 is equal to 4. So I've solved the inequality. That's the first part of my answer. X is less than 4. And to show that on a number line, let's go draw a number line, and it's going to be 4, can be here, anywhere you want to, but it's just less than, so not a filled in circle, and we're going to the left of that 4. Anything less than 4 will satisfy your inequality. That is it. Question 3. I always say if you've got a bracket, probably a good idea to expand it. You could, on this one, divide through both sides by 5, but probably we're going to expand the brackets here. That's not a bad thing to do. So let's go and expand the brackets. So 5 times x is equal to 5x. 5 times 3 is equal to plus 15. Let's write this a little bit neater. So plus 15. And that is greater than or equal to 60. And now that's an inequality that is in the same format as question 2. So let's go and take away 15 from both sides. Take away 15, because then what happens there? These two, they're going to cancel, which is good. And we're left with, on the left-hand side, 5x being greater than or equal to 60 take away 15, which is equal to 45. So 5 times x, so let's go and divide both sides through by 5. Divide by 5, that's good, because then the 5s, they cancel, and you've just got left over isolated x being greater than or equal to 45 divided by 5 is equal to 9. So I've solved my inequality. That is my answer. Okay, and on a number line, let's go and draw that over here. Okay, just a quick sketch. So bigger than or equal to 9, so your number 9 is here. Greater than equal to 9, so your number 9, let's fill it in, and then everything bigger than or equal to 9. And there we go. Okay, last but not least is a bit more of a tricky one, but nothing we can't handle. The issue is we've got our x's on both sides of the inequality, and we've got numbers on either side of the inequality. You want to get your x's onto one side, your numbers onto the other side. Let's begin by getting rid of that minus x by adding it on to both sides. So add x, and let's go and add on x onto my left-hand side, because then what happens there? Well, then these two, they cancel, which is useful. And over here, I get a 13x add 1x, which is 14x. I've got that plus 3, and that is greater than 45. And the x's over here, they've cancelled, so they just disappear. And now this inequality is in the same format as this one up here. So this is something that we can solve now nice and easily. We can go and take away 3, take away 3, which is good, because then these cancel, and we've got 14x left over on the left-hand side, being greater than 45 take away 3 is 42. Divide both sides by 14, divide by 14, and then what happens over here? These cancel, and we're left with x being greater than 42 divided by 14 is equal to 3. So your answer, x is bigger than 3. That is my inequality solved, which is good. X bigger than 3 on a number line. Let's go and draw it in black over here. So bigger than 3, so your number 3 is going to be here. A non-filled in circle, and anything bigger than 3 looks like that. Okay, so if you pause the video and give this a go, and you've got those all correct, fantastic. If you didn't, you can always work through with me and go through those again. Just one really important thing to mention, which is this, is that if you multiply or you divide by a negative number, something really important happens, and we'll go through that now. So let's just say, let's go through an example. If we had something like, I don't know, 5 is bigger than 3, that is true. So to make it really clear, this reads that 5 is bigger than 3, which is true. That is definitely a true statement. But let's just say, right, I go and multiply now, or divide both sides by a negative number. So let's just do something really simple. Let's times both sides through by negative 1. Maybe you're thinking, well, why would I need to do that? It's really useful when you solve some equations to do this. But let's times the whole equation by negative 1, and we can do that because you can times an equation or divide by whatever you want to. 5 by negative 1 would give you negative 5. If I keep the inequality sign the same, 3 times negative 1 gives you negative 3. Well, this statement now reads 3 minus 5 is bigger than minus 3. And does that make sense? Is negative 5 bigger than minus 3? That statement does not make sense. Okay, the one above does. 5 is bigger than 3, but negative 5, it is not bigger than minus 3. Okay, we can see that number line. Minus 5 is over here. Minus 3 is up here. Minus 3 is bigger than minus 5. So the key thing here is this, and let's get rid of this so we can see what is going on. When you multiply or you divide an inequality by a negative number, you must reverse the sign. So here, because I times through by negative 1, I've got to, and that's the key thing here, I've got to reverse the sign. So let's just go and do that in here. Okay, I times through by minus 1, I've got to change the sign to this. This now reads negative 5 is less than minus 3, which does make sense. Okay, so let's write that over here. So this now reads minus 5 is less than minus 3, which does make sense. So that's really important. So make a note of that if you need to. So you can try and solve these two inequalities below, knowing this really important key fact, because we're going to need it in these two examples. So let's go through the first one together. If you want to, you can try these yourself, and then we'll go through them anyway. If not, you can just go through with me. So again, solve the inequalities below. Again, I want to get x on its own with some inequality isolated. So we can begin here. I've got a 7 take away x. Let's go and take away that 7 from both sides to begin with. That's a good place to start. Okay, but you'll see in a second what the issue is going to be. And I'm left with, over here, minus x being greater than or equal to 15 take away 7, which is equal to 8. I've got minus x bigger than or equal to 8. I haven't solved it. I've got to get x on its own. And currently I've got minus x, which isn't useful. To get rid of that minus x, I can times through the whole equation by negative 1. Okay, because then minus x times by negative 1 gives me positive x. But because I've times through by a negative, I've got to reverse that sign. I've got to flip it the other way around and say that x is less than or equal to 8 times negative 1, which is minus 8. Okay, just to solve the inequality, not on a number line. So this here is just my answer. X is less than or equal to 8. So you can see the sign has flipped from the start to the other way around because I times through by a negative. Good. The second one, I've got 3 take away x over 5 is less than or equal to, sorry, it's just less than 2. Let's begin here. I've got the whole thing here being divided through by 5. Let's get rid of that by timesing through both sides by 5 to begin with, because then what happens there? Then these two, they're going to cancel, which is useful. And I'm left with, on the top of that fraction, just 3 take away x being less than 2 times 5 is 10. And that's going to take away 3. It's going to take away 3 because then these two, they cancel, which is good. And again, I'm left with negative x, so minus x being less than. 10 take away 3 is 7. I've got minus x. I want to get x on its own if I'm solving. So let's go and times through again by minus 1. Because then minus x times by minus 1 gives me positive x. But because I've times through by negative 1, I've got to flip this sign the other way around and say that x is greater than 7 times by minus 1, which is negative 7. So that there is my answer. Okay, so just be wary. If you times by a negative, you flip your sign over when you times through by that negative. And that is it. Okay, hopefully that was useful. And on to the next video. Thank you.